Lesson 11-2B, Summarizing Categorical Bivariate Data. So this lesson is just a review of what we've been going through with univariate and bivariate data. So using a two-way frequency table, given marginal and conditional relative frequencies, you can construct a two-way frequency table to summarize the data. And we've already gone through how to create a frequency table. So this would be a more review of putting them together. So our first question. A study by Edison Research found that 37% of the U.S. population aged 12 and older regularly listen to podcasts every month. Of those who regularly listen to the podcast, 20% are aged 55 and older, while about 53.5% of those who do not regularly listen to podcasts are 12 to 54 years old. Construct a two-way relative frequency table of this data. Round to the nearest 1/10 of a percent if necessary. So let's look at our table here. We have our two categories on the left-hand side, so there are subcategories, 12 to 54-year-olds, and then 55 and older. And then we have at the top two more subcategories, does listen and does not listen. And so we're going to fill in the rest of the table, and these are all percentages, remember. But we weren't given any individual numbers besides percentages in the word problem. So we're going to have to figure all of this out without the actual numbers. Now, if we go back to the problem, we already had the 37% in there. So 30% of the U.S. population aged 12 and older regularly listen. So that's 37% of the people 12 and older. Of those who regularly listen to podcasts. So we have to look at the column that has listening to podcasts. 20% are age 55 and older. So if I go to this column right here, does listen. Of this 37, that 37%, it said that 20% are 55 and older. So at this box right here, that is 20% of 37%. So to find that, we're going to take our calculator. And we're going to go 37%, so 0.37. Then we're going to multiply that by 0.2. So 20% of 37%. And then we multiply that by 100. And that will give us 7.4%. So 7.4% are 55 and older. Now to find out the top one, we could use another percentage, but we could just subtract 37% and 7.4% to figure that out. So 37 minus 7.4% gives us 29.6%. So 29.6% of those who listen are 12 to 54-year-olds. Now going back, we have another percent as well. 53.5% of those who do not regularly listen to podcasts are 12 to 54-year-olds. So those who do not. So let's go over here. 53.5%. Yeah, so 12 to 54-year-olds that does not. So this piece is 53.5% of all those who do not listen. Now, we know that one of the totals, the total in this box right here, the total of totals, that is 100%. So 100% of the people who took the survey. Now, if I look at the very bottom, this box right here, 37 plus what gives us 100? We take 100 minus 37. This is 63% of the people who do not listen. So now if we define this upper box, the 12 to 54-year-olds that do not listen, if we take 53.5% or 0.535 So 0.535, and we multiply that by our 63%, which is 0.63, and then multiply that by 100. That gives us 33.705. So we can round that to the nearest tenth. It tells us nearest tenth, so that'd be 33.7%. So 33.7% of all the people that do not listen are from the ages of 12 to 54. Now I can find the middle box by taking 63% minus 33.7%, and I get 29.3%. And now to find the totals on the rows, I can just add straight across. And we have 29.6 plus 33.7, and that gives us 63.3%. And then 7.4 plus 29.3 gives us 36.7%. And if you would add straight down, that still gives you your 100%. This next slide tells you another way of solving that. So here you can use a tree diagram to calculate the joint relative frequency. To do that, you just multiply the frequencies of each branch of the tree to find the joint relative frequencies. Now, I did it a little bit different way, but we started off with this 37%. And we know that if you add these two, this will give you your 100%. So this is your total. They gave us this 20% here, and they gave us this 53.5%. So what they're telling you to do is if you take 37% times the 20%, that will give you the percentage who are 55 and older. Where did this 80 come from? Well, if this part was 20% of it, 80% is the other group. And so we didn't use the 80%. So if I went back, if I wanted to do 80% of 37%, I would do 0.37 times 0.8 and then multiply by 100. That's your 29.6. So there's multiple ways of doing that. If you find one of these and you know the total, you can just do the subtraction. But that's just another way of how they got their solutions. We're going to just skip the describe how to interpret the tree diagram and go to our next one. According to the Centers for Disease Control and Prevention, 7.7% of the U.S. population have asthma. Of those who do not have asthma, about 50.4% are female, while about 39.5% of those who have asthma are male. Based on the given information, construct a two-way relative frequency table of this data, round to the nearest tenth of a percent if necessary. So here I have the tree diagram for us. And it's that according to the Centers for Disease Control and Prevention, 7.7% of the population have asthma. So if 7.7 has asthma, what percent does not? You would just take that 100 minus the 7.7, and you'd have 92.3. So 92.3% does not have asthma. And then if we wanted to find out, we can now use the percentages and its total here. But before we do that, let's fill in these middle boxes. So if this box right here, this is 39.5, it has to add this box and this box have to add up to 100. If I take 100 and I subtract 39.5, I would get 60.5%. And down here, if I already have 50.4%, I can take 100 minus 50.4, and that gives me 49.6%. And so from here, we can use all the information to find out what percent is male that has asthma, which percent has females have asthma. So to do that, I would take 0.077. Let me put my calculator up here so then you can see doing that. So I'm going to take 0.077, so that's my 7.7%. I'm going to multiply that by 0.395. And then if I multiply that by 100, I get 3.0. So 3.0 would be the number of males who have asthma. Now to find the females who have asthma, we're going to take the 0.077. We're going to multiply this by 0.605, so the 60.5%. And then multiply that by 100. That gives us 4.65, so to the nearest tenth would be 4.7%. 4.7% of the students, of the people who have asthma are female. Now, if you add 3 and then 4.7, that gives you your 7.7%. So I'm going to go right to my table now, and we're going to put those numbers in here. So male, we said was 3% that have asthma. Female was 4.7%, and the total was 7.7%. And then we already know that 92.3% of the people do not have asthma. And if you add the bottom two, that gives you 100%. So now we're going to find out how many male and how many female do not have asthma. We're now going to take our 0.923 and multiply that by 49.6%. So we have 0.923 times 0.496. Then we're going to multiply that by 100. And that gives us 45.8%. So 45.8%. And then for female, we would take 0.923 times 0.504 times 100 gives us 46.5%. Then we go back to our table. Males that do not have asthma was 45.8%, and females were 46.5%. And if you add straight down, you get your 92.3. So now if I add straight across to find the totals, this would give us 48.8%, and then 4.7 plus 46.5 will give us 51.2%. So that is one way of doing the first types of problems. Next part is a segmented bar graph. A segmented bar graph is a stacked bar graph where the sum of the segments in each bar is 100%. Segmented bar graphs are useful for comparing the data that make up each category. So here's an example of a bar graph. To the right hand side here, you can see we have two bars, has flu and does not have flu, but they're color coded. You have a smaller bar on top of a bigger bar, or a larger bar on a smaller bar. But down here is the key that tells you what the colors mean. And so we're going to use this to answer some questions. On average, 8% of the US population gets sick with the flu each year. Based on the accuracy of the most common flu tests, the segmented bar graph shows the conditional relative frequencies of test results based on whether a person has the flu. Interpret the data, round to the nearest tenth of a percent if necessary. When they're talking about conditional relative frequency, there's a condition. So given that they have flu, what's the probability that they test positive? Or given they have a flu, what is the probability of them testing negative? That's what they mean with conditional relative frequency. So our first question we want to look at is, how likely are false positive results and false negative results, and how do these compare? So just to make things a little bit clear for you, a false positive means that someone tests positive even though they do not have the flu. And a false negative means that someone tests negative even though they do have the flu. So now if we look at how likely are false positive results. So the false positive, I have to look at those that do not have the flu. Those that do not have the flu is right here in this bar, a false positive. So that means they don't have the flu, but it shows that they do have, that they tested positive, and that would be 7.5%. Because here, this is the positive color. Right here, this whole bar here tells us that this is, you don't have the flu, but according to the test, it says you tested positive for it. So that's a false positive. For a false negative, you're going to have to look at those who have the flu. So they have the flu, but they had a false negatives, which means they tested negative on it. So that would be this color. That would be 40%. 40% are false negatives. So how do these compare? There's a much higher likelihood to receive a false negative than receiving a false positive. Letter B, what percentage of the population tests positive? Okay, so we were told in the problems, if I go back, it said that on average 8% of the US population gets sick with the flu. So we're going to use that 8%. We're going to use 0.8 or 0.08 for the 8%. So the 8% of the population, what tests positive? So test positive, I have to look at all the blue. So if they have the flu, 8%, so 60% of the 8% of people who have the flu tested positive. So if I take 0.6, times 0.08 and then multiply that by 100, we should get 4.8. So and let me put this times 100. So 4.8% have the flu, were tested positive. But there's also another group here. This group right here also tested positive. They just don't have the flu. So to find that percent, we're going to have to find out what percent of the population did not have the flu. So if 8% had the flu, that leaves us with 92%. So you just take your 100 minus the 8%. That gives us your 92%. So 92%, so I'm going to use 0.92. And it says 7.5% of the 92% tested positive. So this would be 0.075. And we're going to multiply that by 100. So we grab our calculators again, and we're going to do 0.075 times 0.92. And then we're going to multiply that by 100. That gives us 6.9%. Now if I add these numbers together, I get 7, 10, 11, 11.7% of the population tested positive. So that is really these two blue pieces. How else could you represent the data presented in the segmented bar graph? We could make a two-way conditional relative frequency table with whether a person has a flu as one category and the test results as the other category. And then we can use a conditional relative frequency given in the graph to complete the table. That is up to you with that one. But here we did the same thing in this problem that we did in the last one. It's just how they presented the material was a little bit differently. Try another problem. AP exams are scored from 1 to 5. Many colleges will grant a student college credit for a score of 3 or higher on the AP exam. In 2019, about 35% of Florida students who took the AP biology exam were in 12th grade. The segmented bar graph shows the conditional relative frequencies of AP biology exam scores based on the grade. Interpret the data, round to the nearest 10th of a percent if necessary. So we want to keep in mind this 35% of those who took the AP exams were 12th graders. So I'm going to put that up here, 35% 12th grade. How likely is it that a 12th grade student who took the AP biology exam scored a 3 or higher? We're going to look at this column right here because this is the 12th grade. So given it's this, 3 or higher is the blue. So we're looking here, and that would tell us that 56.6% of 12th graders who took the AP biology exam scored a 3 or higher. Letter B, what percentage of the students who took the AP biology exam were not in 12th grade and earned a score less than 3? So if this column right here, the 12th grade column, if that's 35%, that means this bar has to be 100 minus 35. And 100 minus 35 would give us 65%. So this is 65%. So 65% of the students were not 12th graders who took the AP biology exam and then earned a score less than 3%. Less than 3% is 40.9. So they're saying what percentage of the students who took the AP biology exam were not in 12th grade and earned that one. So we're going to take our 0.409, so 40.9% of the 65% of the students who scored less than 3. So on our calculators, we have 0.409 times 0.65 times 100. This is going to give us the nearest 10th, 26.6%. So let me put this times 100. 26.6%. And our last one year, about 29% of all vehicles purchased in the U.S. were new. The segmented bar graph shows the conditional relative frequencies of vehicle financing based on whether a person purchased a new or used vehicle. Interpret the data around the nearest 10th of a percent, if necessary. So what percentage of purchased vehicles were financed? That's the main question we want to answer. So 29% of all vehicles purchased were new. So this is 29%. And if that's 29%, the other one would be 100 minus 29%, which is 71%. Okay, so we want to find out the percentage of purchased vehicles were financed. Financed was 70, it was the blue bar. So based on the new ones, if I did 85.4%, so that's 0.854 times 29%, so 0.29 times 100, that will give us the percent of all new vehicles who were financed. So in our calculators, we have 0.854 times 0.29 times 100. That gives us 24.8%. So that's this part. We also, there's blue pieces over here. So I have to find that one. And to do that one, we're going to take so 0.555 times 71% of it would be 0.71 times 100. So we grab our calculator. We have 0.555 times 0.71 times 100 equals 39.4. Now if I take my two percentages, so I'm going to take 39.4, I'm going to add 24.8. That should give us the total amount that were financed. So 39.4 plus 24.8 gives us a total percentage of 64.2%. So that is our lesson on summarizing categorical bivariate data.